Okay, this is a question which is based on a spring system. Okay, so for a spring system, always remember force equals to minus kx. This is the thing you need to remember for a spring system, right? Now, the question is asked, the spring is hung vertically and an object of mass m is attached to its lower end. Under the action of the load mg, the spring stretches a distance t from its equilibrium position. So now basically there is a spring like this here. It's the equilibrium position, but now from this spring there is a ball of mass m is basically a ball of mass m is attached. Okay, so if it is attached, that means it is doing some displacement d. It is covering a distance t. Okay, and it is not now in its equilibrium position. So if a spring is stretched 2 cm by a suspended object having a mass of this, what is the force constant of the spring? That means F equals to minus kx. We need to find this k. So k is the force constant. So first of all, we will make a free body diagram as we do in all of the questions of force. So mg is the direction of the force which is due to the gravity. But due to the spring system, basically there is a opposite force which is there. So it is Fs. So can I say Fs equals to mg, right? Due to the free body diagram. And now we know Fs equals to kx, right? We are not considering this negative sign. Why? Because it is already taking in the action. Because this force is due to the spring. Okay. Now, so that means I can write kx equals to mg, right? So if I'm writing kx equals to mg, that means k equals to mg by x, and we can find out this k. Because m is given 0.55, g we all know, and x is displacement 2 into 10 to the power minus 2 meter. So we can find out k, which is 2.7 into 10 to the power 2 Newton per meter, right? Now, there is a B part. How much work is done by the spring on the object as it stretches through the distance? Now, we need to find out how much work is done when it is stretching through the distance, like this work now. Okay. So we all know F equals to minus kx. We all know. Now we will consider this minus kx because now we need to find out this work done only. Okay, so we will consider this negative sign. Now there is no force which is balancing here. Okay, so minus kx dx, and it is 0 to 2. Initial is 0 and the displacement what it has done is 2, right? So initial is 0 and 2 is the final one. So we need to integrate this. Limits are 0 to 2, and we all know if we need to do the integration of this 0 to n x to the power n. How do we do the integration? N x n plus 1 over n. So this is how do we do the integration. So it is now 0 to 2 x to the power 2. That means we will do 2x. So we will do the integration of it and we will find out the value, right? So we will find out it 2x 3 over this is n is 2, right? This is the integration. Now we need to find out the integration of x. So x will be 0 to 2 if I need to find out x. So it will be n is 1, x n plus 1 over n plus 1, right? So it will be x square by 2. So we have taken out the integration. So I am just putting the values and the limit, and we have found out the work done minus 5.4 into 10 to the power minus 2 joules. So when we are solving these equations, please consider how to do the integration.